Previously, we have seen different circuits of op-amps, including inverting and non-inverting amplifier, and we have also seen some applications of op-amps, right? So today we will solve some numerical examples on these circuits. So this is the first one we have. Here, you are asked to find the gain of a non-inverting amplifier if RF is equal to 10 kilo ohms and R1 is equal to 1 kilo ohm. So these are the things given. It is given it is a non-inverting amplifier. You have been given with the value of RF and R1. You have to find the gain of a non-inverting amplifier. So you know the given things. First write the given things, RF and R1, that is 10K and 1K respectively. So you know the output of a non-inverting amplifier. For a non-inverting amplifier, it is V0, that is equal to 1 plus RF by R1 into Vin, right? It is 1 plus RF by R1 into Vin. Then what is the gain here? This 1 plus RF by R1 is the gain, right? 1 plus RF by R1 is the gain. So you know what is RF, what is R1, just substitute, you will get the gain. It's a very simple thing. Gain is equal to 1 plus RF by R1, just substitute 1 plus 10K by 1K. 10K by 1K is 10, you know, 1 plus 10, that's 11. So gain is 11. That means whatever you give at the input, it will be multiplied by 11 times when it is obtained at the output, right? The output is 11 times that of the input. That's the gain of a non-inverting amplifier, right? Just the formula 1 plus RF by R1, that will give you the gain. If you know RF and R1, just substitute and get the answer. A similar one, next problem based on non-inverting amplifier itself. A non-inverting amplifier has closed loop gain of 25. If input voltage Vi is equal to 10 millivolts, RF is equal to 10 kilo ohms, determine the value of R1 and the output voltage V0. So you are asked to find the value of R1 and the output voltage. You have been given that the gain is 25, right? The closed loop gain means there is a feedback resistance. That's why, you know, it's called the closed loop gain. Whatever the gain you have, that's the closed loop gain. That is given as 25. Input voltage is 10 millivolts. RF is 10 kilo ohms. So you are asked to find the other resistance, that is R1, and the output voltage V0. So you know the equation for the gain. You know, first write the given things. Gain is 25. Vi, that is the input voltage, is 10 millivolts. RF is 10 kilo ohms. So you know that the gain is 1 plus RF by R1. In case of a non-inverting amplifier, we have just seen the gain is 1 plus RF by R1. We have been given that this gain is equal to 25, right? So given that this gain A is equal to 25, that means 1 plus RF by R1 is equal to 25, right? 1 plus RF by R1 is equal to 25. So what is RF by R1? RF by R1 is 25 minus 1, that is 24, right? RF by R1 is 25 minus 1, that is 24. So RF by R1 is equal to 24. So what is R1 equal to? R1 will be equal to RF by 24. You just rearrange that thing. R1 is RF by 24. RF is given as 10 kilo ohm, right? Divided by 24, that's how much? 10 kilo ohms divided by 24. So find this, that will be R1. 10 kilo ohms by 24, how much is it? Yes, 416.6666, right? 10 kilo ohm divided by 24, that is 416.666. You can approximate to 416.67 ohms, right? So that is the value of R1 that you have to use in the circuit. You are also asked to find the output voltage V0, right? What is output voltage V0? V0 is the gain multiplied by the input. You have the gain, you have the input voltage, you can find the output voltage, right? So V0 is 1 plus RF by R1 into Vin. In case of it is given, it is non-inverting amplifier. So V0 is 1 plus RF by R1 into Vin. What is this 1 plus RF by R1? That is the gain, right? So 1 plus RF by R1, that is the gain. That is equal to 25. It is given the gain is 25. So just 25 multiplied by what is the input voltage? Vin or Vi. That is 10 millivolts, right? So 25 into 10 millivolts, that's how much? 25 into 10, that is 250 millivolts, right? 250 millivolts. You can also write it as 0.25 volts or 250 millivolts is fine. So that's the output voltage. So for 10 millivolts of input voltage, you are getting 250 millivolts of output voltage. That means your input is amplified by 25 times because the gain is equal to 25, right? So that's how you can find the value of the output voltage in case of amplifiers. To take another example, here you are asked to design an inverting and non-inverting operational amplifier to have a gain of 50. So here, you have not been given with any component values like resistances or input voltage or something like that. You have been given with the gain. You are asked to design an inverting and non-inverting operational amplifier. So it's actually two different problems. One is an inverting amplifier with a gain of 15. Another one is a non-inverting amplifier with a gain of 50. So design means what? You have to find the values of the components that you're going to use, right? You're finding the values of components that you're going to use. So gain is given as 15. In amplifier circuit, you have two resistances, RF and R1. You have to find the values of that. Okay. And once you find the values of RF and R1, you have to draw the circuit to complete the design, right? First, we will consider an inverting amplifier. Given the gain is 15, for an inverting amplifier, V0 is minus RF by R1 into Vin, right? This is the output voltage in case of an inverting amplifier. That is minus RF by R1 into Vin, right? So gain is RF by R1. RF by R1 is given as 15, right? Gain is given as 15. That is RF by R1 is 15. So what is RF? It is 15 into R1. If I take it to the other side, it is 15 into R1. Right. So now you have this relation between the two resistances, RF and R1. You have to just, find these values of RF and R1. So what we can do is we will just take one value of R1 and you will get the corresponding value of RF. Right. So let us take R1 is equal to 1 kilo ohm. If I take R1 is equal to 1 kilo ohm, what will be RF? 15 into 1 kilo ohm. RF will be equal to 15 kilo ohm. So this value of RF will be dependent on what value of R1 I take, right? So you are free to choose any value in this case. You can take 100 ohms, you can take 1 kilo ohm, you can take 10 kilo ohm. Depending on that, you will get the value of RF, right? So here, since I have taken R1 is 1 kilo ohm, for my design, I will get RF is equal to 15 kilo ohm. So now once we have got the values of this RF and R1, we have to draw the circuit of inverting amplifier and put the values of R1 and RF, right? So this is a circuit of an inverting amplifier. R1 is 1 kilo ohm, RF is 15 kilo, right? This is an inverting amplifier with, Vin is given at the inverting input terminal. Here is V0, this is a feedback resistance. Its value you have found to be 15K, R1 you have found to be 1K. Non-inverting input terminal is grounded, right? So this is the way you have to get the component values and put them in the circuit diagram to complete the design. So we have finished one part of the problem, that is inverting amplifier with gain of 15. There is another thing that it's also given to design a non-inverting operational amplifier to have a gain of 15. So for a non-inverting amplifier, we know the output voltage is equal to 1 plus RF by R1 into Vin, right? So here the gain is 1 plus RF by R1. So if 1 plus RF by R1 is equal to 15, right? If 1 plus RF by R1 is equal to 15, what is RF by R1? RF by R1 is 15 minus 1, that is equal to 14. Then RF will be 14 into R1. So here again I will take any value of R1. Let us take R1 is equal to 1K, right? Similar to the previous one. If R1 is equal to 1K, then RF will be 14 into 1K, that is 14K, right? So depending on what value of R1 I take, I will get the corresponding value of RF. So here again, you're free to choose the R1 whatever you want. You can take it as 100 ohms or 1K or 10K, whatever value. Depending on that value, you will get a proper value for RF. So now once you have got these values of R1 and RF, you draw the circuit diagram and put these values in that circuit. For a non-inverting amplifier, this is the circuit, right? Input is at the non-inverting input terminal, Vin. Then inverting input terminal is grounded through a resistance R1, that is 1K. And there is a feedback resistance from the output to the non-inverting input terminal, that is RF. Its value you have found to be 14K, right? 1K R1 and 14K RF. So this is the designed circuit, right? So if any gain is given, now you know how to design a circuit for inverting as well as non-inverting amplifier, right? So we will take another example. Here it is given, it is a non-inverting amplifier circuit. A non-inverting amplifier circuit has an input resistance of 10K and feedback resistance 60K with load resistance of 47K. Input resistance of 10 kilo ohm, feedback resistance of 60 kilo ohm, and load resistance of 47 kilo ohm. You are asked to draw the circuit and calculate the output voltage, voltage gain, load current when the input voltage is 1.5 volts. So how to do this? So here, there is input resistance. Input resistance is R1. Okay, whatever R1 you have, that is the input resistance. Then the feedback resistance is RF. Another thing is given, that is load resistance. This we had not considered till now, right? So we had just obtained V0. We did not consider a resistance at the load, right? Now since it is given, we need to consider that. You are asked to draw the circuit. You are asked to draw this particular circuit, right? You are also asked to calculate output voltage V0, voltage gain A, and load current when the input voltage is given. Input voltage is given as 1.5 volts. So from the given parameters, you can draw this circuit like this. It is a non-inverting amplifier. So input is given at the non-inverting input terminal. It is 1.5 volts. Then input resistance R1 is given as 10K. Feedback resistance is given as 60K. Our circuit was limited only to these two, right? These two resistances, R1 and RF. Now, since load resistance is given, that load resistance is across the load. I mean, at the output, wherever you are measuring the output, that is the load resistance. You are measuring this V0 across RL. Here there is RL, which is equal to 47 kilo ohm, right? This is one extra thing you need to consider in this case because it is given. Load resistance is given. You are asked to find the output voltage. What is output voltage? In case of a non-inverting amplifier, output voltage is 1 plus RF by R1 into V in, right? So these are the things we have. R1 is 10K, RF is 60K, RL is 47K, V in is 1.5. Output voltage is 1 plus RF by R1 into V in. Just substitute. RF is 60K, R1 is 10K, V in is 1.5. Can you substitute and tell me the answer? 60 by 10K is 6. 1 plus 6 is 7. 7 into 1.5. That's how much? 10.5. Exactly. Output voltage is 10.5. So, but that's not the only thing asked. You are also asked to find the voltage gain. What is the voltage gain? Voltage gain is 1 plus RF by R1, right? Voltage gain A is 1 plus RF by R1. RF is 60K, R1 is 10K. So just substitute. 60 by 10 is 6, 1 plus 6 is 7. So voltage gain is 7. That means whatever you give at the input, it is multiplied by 7 times and obtained at the output. One more thing is asked. You are asked to find the load current. Load current is IL, current through this load. Current through this load is equal to voltage divided by resistance. What is the voltage across the load? Output voltage, that is V0. And the resistance is RL. So IL is V0 divided by RL, right? IL, load current, is equal to V0 divided by RL. V0 is 10.5 you have obtained. RL is given as 47K. So what is the load current? Just calculate and tell. 10.5 volts divided by 47K. That will give you the current. You can write the answer in milliamps. 10.5 divided by 47K. How much is the answer? 223.4. It's actually 223.4 microamps. So in terms of milliamps, it is 0.2234, right? 0.223 milliamps, right? 0.223 milliamps. It's 223.4 microamps. In terms of milliamps, it is 0.223 milliamps, right? So that's the answer. So, here there was one thing like load resistance. So you need to consider that at the output, that's the load resistance, and you can find the load current from that. We will take another example. Here, for an op-amp circuit shown in the figure, you are asked to find the output V01 and V02. You are also asked to write the function of each op-amp used. See, there are two op amps here. That means there are two different circuits which are cascaded. The cascaded means which are connected together. The output of one is connected to the input of the other. This is one op amp, it is used as one particular application. This is another op amp, it is used as another application. So the output of this is connected to input of this particular. So by looking at the circuit, you have to tell what is the application or what is the function of each op amp. It is not mentioned in the question. By looking at the circuit, you should be able to find what is the function of this op amp. Can anyone tell me what is the function of op amp 1? What is the function of op amp 1? We have seen the different circuits of op amps. In this op amp 1, the input is connected to the non-inverting input terminal and the output is connected to the inverting input terminal. There is no input resistance or feedback resistance. What kind of circuit is this? Can you look at this circuit? Isn't it the same? At the input, at the non-inverting input terminal, we have connected input voltage. Inverting input terminal is connected at, from V0, no resistance is used. The output will be the same as the input, isn't it? So it's a voltage follower, right? So in a voltage follower, the output is equal to input, right? Output is equal to input. Your output is V01, that should be equal to Vin, right? So first stage is a voltage follower. The first stage is a voltage follower. In a voltage follower, the output V01 is equal to Vin. Since Vin is given as 1.5, output is also 1.5. Which output? Its output, only V01, that is equal to 1.5. Now tell me what is the function of this op amp 2? What is its, what circuit is it? What is it used as? What is its function? Op amp 1 function is voltage follower. Op amp 2 is, look at the circuit, the input is given at the inverting input terminal. Non-inverting input terminal is grounded. There is a feedback from output to the inverting input terminal. This is R1, this is RF. You can take. So what is it? What circuit is it? It is inverting amplifier, right? Why? Because input is given at the inverting input terminal and non-inverting input terminal is grounded. So it is inverting amplifier with input as V01, output as V02. R1 is 20K, RF is 100K. So the function of the second op amp is inverting amplifier, or the second stage is an inverting amplifier with R1 is equal to 20K and RF is equal to 100K, right? So for an inverting amplifier, the output voltage is minus RF by R1 into Vin. Here output is V02, Vin is V01. So minus RF by R1 into V01. So RF is 100K, R1 is 20K, right? Substitute, RF is 100K, R1 is 20K into V01 is 1.5. So what is the answer? 100K by 20K is 5 into 1.5. That is minus 7.5 volts, right? So this is the output at the end of the circuit. After both the stages. So whenever such things are given, you should do individually. You should get the output of each stage or each op amp individually, and finally you will get the answer for the end output, right? Your V01 is same as the input because this stage, its function is voltage follower. V02 is minus RF by R1 into V01 because this is an inverting amplifier. I hope you understood this. Next, we will move on to the next application, that is inverting summing amplifier. Here you are asked to calculate the output voltage of a 3-input inverting summing amplifier given R1 is equal to 200K, R2 is 250K, R3 is 500K, RF is 1 mega ohms. So these are all given in the question. V1, V2, V3 are also given as -2, -1 and +3 volts. Right? We are asked to find the output voltage. You know the equation for output voltage, right? So we will just first write the given things. So this is the diagram of an inverting summing amplifier. Diagram is not given, so but just for reference, you can draw that diagram. V1, V2, V3, and this is V0. This is RF, R1, R2, R3, I1, I2, I3, I4. So anyway, all the values are given. First write the given things. R1, R2, R3, RF, V1, V2, V3. All these are given. You know what is the output voltage of an inverting summing amplifier, right? What is it? V0 is equal to minus of RF by R1 into V1 plus RF by R2 into V2 plus RF by R3 into V3, right? If it is 3 input, it is this particular thing. You have all these values, just substitute and get the answer. RF is 1 mega, R1 is 200K, R2 is 250K, R3 is 500K, V1 is -2, V2 is -1, V3 is +3, right? +3. So just substitute. 1 mega divided by 200K. 1 mega is 1 into 10 raised to 6, 200 into 10 raised to 3, right? Just find these values. What is 1 mega by 200K? It is 5 multiplied by -2. Then 1 mega by 250K, it is 4 into -1. Plus 1 mega by 500K, it is 2 into +3. So what do you get? 5 into -2 is -10. 4 into -1 is -4. Plus 3 into 2 is 6. -10, -4, plus 6. What is the answer? -14 plus 6 is -8. Minus of -8 is +8 volts. Right? So it's a simple calculation. When all the values are given, just substitute them, you'll get the answer. So answer is 8 volts. That means whatever the inputs you have given, they are getting added up along with certain gain to get the output voltage as 8 volts. So there is a similar example. Next one, you are asked to determine V0 for the circuit that is shown in this figure. The circuit is given like this. It is not mentioned here what circuit it is, but by looking at the circuit, you can tell what it is. Now tell me what this circuit is. Non-inverting input terminal is grounded. At the inverting input terminal, you have 3 inputs connected through 3 resistances, and it is also connected to the output through a feedback of 10K. So what is this circuit? Inverting summing amplifier, right? It is inverting summing amplifier. So just like the previous one, what is the, first write the given things. V1 is 0.1, V2 is 0.2, V3 is 0.3, R1 is 20K, R2 is 10K, R3 is 50K, RF is 10K. First write those given things. It's 3 input inverting summing amplifier, right? So R1 is 20K, R2 is 10K, R3 is 50K, V1 is 0.1, V2 is 0.2, V3 is 0.3, RF is 10 kilovolts. First write all the given things. Then the output of a 3 input inverting summing amplifier is the same. That is V0 is minus of RF by R1 into V1 plus RF by R2 into V2 plus RF by R3 into V3. Substitute that. RF is 10K, R1 is 20K, R2 is 10K, R3 is 50K, V1 is 0.1, V2 is 0.2, V3 is 0.3. Just calculate. It's simple. Tell me the answer. Minus 0.31. So if you calculate this, you'll get 10K by 20K is 0.5 into 0.1 plus 10K by 10K is 1 into 0.2 plus 10K by 50K is 0.2 into 0.3. So if you simplify and further calculate, you'll get it as minus 0.31 volts. So this is how you can find the output voltage of a 3 input inverting summing amplifier. There are some more examples. We will take that up in the next class.